Hi everyone. This is an example of a limiting reactant stoichiometry problem where we're asked to determine the amount of the excess reactant. Now, we're going to follow our same 4 steps, only there's an extra wrinkle that we have to follow through with at the very end. After our solve step, there's a subsequent step. Here's the question. Chloroform, CHCl3 gas, reacts with chlorine gas to form carbon tetrachloride and hydrogen chloride. If 25.0 grams of each reactant was used, determine the limiting reactant and calculate how much mass was in excess. We're doing our best to look for some keywords to help wrap our heads around what the reaction is. It's pretty explicit in the first sentence. CHCl3, chloroform, reacts with chlorine gas to form, there's a keyword, to produce carbon tetrachloride and hydrogen chloride. Let's get the reaction down. CH3L3 reacts with chlorine gas. Chlorine's diatomic, it's Cl2. To produce carbon tetrachloride, carbon CCl4, tetra means 4, and hydrogen chloride. Let's balance this equation. It just works out to be balanced as a matter of fact. 1 carbon, 1 carbon, 1 hydrogen, 3, 4, 5 chlorines in total on the left-hand side, and on the right-hand side, 4, 5 chlorines. It's a balanced chemical equation, just with all ones. How nice is that? Let's continue on with our interpretation. If 25.0 grams of each reactant was used, determine the limiting reactant and calculate how much mass was in excess. 25.0 grams of each reactant. So this means here the mass is 25 grams. And for the chlorine, the mass was 25 grams as well. Lots of limiting reactant questions ask us a question about the product. Here, this one's a little bit different. Which one is the limiting reactant and how much was the excess? So we're not even sure what we're trying to solve for just yet. We don't know which chemical is the limiting reactant and which one is the excess. However, we can tell that it's a limiting reactant question in a couple of different ways. First is, it straight up tells us in the wording itself. Determine the limiting reactant, it's a limiting reactant question. However, we also have enough information to find moles twice. As soon as we can find moles twice, it's a limiting reactant question. So here, we have to do mass over molar mass twice. Here, the moles of the chloroform is 25 grams over the molar mass of the chloroform, which is a carbon, 12.01, a hydrogen, 1.01, and 3 chlorines at 35.45 each. It's 119.37. So we can do the calculation here. It's 0.20943, etc. moles. We need to do the same thing for the chlorine. Here the moles are 25 grams over 2 chlorines, 35.45 each, which is 70.9. 25 divided by 70.9 is 0.35269, etc. moles. We have our 2 mole answers. Now we're going to compare them while referring to the balanced chemical equation. The chemical equation says 1 reacts with 1. This is our favorite type of scenario where we have a 1-to-1 ratio, a 2-to-2 ratio, even 3-to-3 if it comes up. If we have the same coefficient for the two reactants, if they're in a 1-to-1 ratio, that's our favorite type of scenario. We're just picking the one with the lower number of moles. In that case, it is a direct comparison. So, because 0.2 is less than 0.35, the chloroform is the limiting reactant. Determine the limiting reactant, we did it. And we have to calculate how much mass was in excess. So here we're looking for the mass of this one in excess. This is important because there's really three different ways we could think about the mass for this reactant. We could think about its initial mass. We could think about the mass that reacts. And we could think about how much is left over afterwards. Because there's extra, because there's excess, there's the initial mass, the change in mass, and the final mass. And this question is asking us for how much excess was there? What's the final mass after the reaction stops? So what we need to do is take a moment, and because we've decided on the limiting reactant, we want to take what we know about the excess reactant and just put it on the side for a second. We need to pretend we don't know anything about the excess one. And we need to do a calculation to find out how much got used up. How many grams of chlorine are going to react with 25 grams of chloroform? So we're going to follow through with the whole stoichiometry problem to calculate how much got used up. Here we go. We're going to always start with the limiting reactant for any stoichiometry itself. It's a little bit repetitive because we already did this operation. It's 25 grams over 119.37 grams per mole. Remember, we're trying to calculate the mass of the chlorine. That's going to feel strange because this is the mass right there, but that's the initial mass. We're calculating how much got used up. So it's times our 1 over 1, and it's multiplied by the molar mass of the chlorine, which is 70.90 grams per mole. Remember, this answer represents how much reacted, how much got used up. We do this, 25 over 119.37 times 1 over 1 times 70.9. This is 14.487, etc., unrounded grams. Now we have one more step to go. The chlorine started at 25 grams. We just did a calculation that 14.487 grams reacted, got used up. So in order to determine the excess, we have a little bit of subtraction to do. The excess is going to equal our 25 grams that we started off with, and we're going to subtract the amount that got used up, this 14.487 number, which is still just sitting on my calculator screen. So I can do that now. 25 subtract the answer that we just got, we get 10.15121052 grams, which now we can think about the significant digits. There's only the one number in the question, 25.0, 3 significant digits. We round this off. It's 10.2. This was the mass of the excess grams. Limiting stoichiometry problems, they really come in two big types. The most common is where we're asked something about the product. However, there are going to be times we can be asked how much was the excess reactant. Things are going to be kept vague there. They don't tell us which chemical was the excess, which chemical was the limiting. We had to make those determinations on our own. The tricky part is to realize that this mass right here was the initial mass. We need to do some stoichiometry in order to determine how much of it got used up. So then we could do an additional step. which isn't here part of our normal 4. When we get this question, how much was the excess? There's always this extra move at the very end where we take the initial mass, subtract how much reacted in order to determine how much is left over, how much was in excess. And I hope that helps.